All right, welcome back. Again, I'm off camera. That way I can show you some rocks and such. So let's talk about the rock cycle. What the heck does that have to do with minerals? Well, you need minerals to make up rocks. And then from there, different combinations of minerals make up different types of rocks. Different types of rocks are created from different processes. Typically, we start the rock cycle, our discussion, with igneous rocks, hot liquid, magma, hot liquid rock cooling below ground or above ground can create different types of igneous rocks. Those igneous rocks, once exposed, are broken down, called weathering, and then that material is eroded and deposited and builds up, compacted together, cemented together to form sedimentary rocks. And then sedimentary rocks, under some heat and some pressure, begin to change and become metamorphic rocks. Now, that's typically how we talk about the rock cycle. Unit 6 will be igneous rocks, Unit 7 will be sedimentary rocks, Unit 8 will be metamorphic rocks. However, the cycle can go anyway. You can go from igneous rocks to metamorphic rocks, back to igneous rocks, right back to igneous rocks, to sedimentary rocks, back to igneous rocks, to metamorphic rocks. So it's not just always a loop. It really depends on what the Earth's doing, a lot of it tied to plate tectonics, as well as the water cycle and atmospheric conditions. So what is the difference between a rock and a mineral? Well, strictly speaking, a rock is a naturally formed, coherent aggregate combination of minerals, two or more, usually, and possibly some other non-mineral matter. All right. So mineral on its own, solid, naturally occurring, inorganic, crystalline, ordered internal crystalline structure, as well as specific chemical composition. Rocks are made up of two or more minerals and sometimes other stuff, other non-mineral stuff. So it's a combination typically of stuff. That's what rocks are. All right. What's cool about rocks is not necessarily their name or what they look like, which, I mean, to some people is kind of cool. But rocks record the history of Earth's processes. Rocks are a story. Rocks tell a story. Rocks are different chapters in the book of Earth. So it's the story that they tell that, to me, personally, is interesting. So let's start with igneous rocks. So igneous rocks formed by cooled and solidifying magma deep below the surface or lava on the surface. So the type of rock formed depends on the cooling rate. Magma below ground will cool very slowly. Lava above ground will cool very quickly. So how fast or slow igneous rock cools will determine the size of the mineral grains in an igneous rock. Sometimes igneous rocks have vesicles or holes. Again, magma is molten rock below Earth's surface. Lava is molten rock above Earth's surface. Where that material cools, how fast it cools, what is in that magma or lava itself, this is what determines what igneous rock will occur. So here's just a shot of a bunch of igneous rocks. Some characteristics you can look at in igneous rocks will be crystal grains. So you can pick out in this rock up here, which is a granite, you can see the different colored minerals. There's some orange stuff, some black stuff, some white stuff, some clear stuff. So you can see the different crystal mineral grains. Good indication of igneous rock. Again, in like this grayish rock down here, you can see the gray matrix and these black crystals. Good indication of igneous rock. Also, though, holes, vesicles. As lava or magma cools, sometimes the trapped gas will come out of that material, leaving behind these vesicles, these holes. You can see some here and some here. So these are good indications of igneous rocks. So let me show you a few here. The lighting here is kind of bad. All right, in any case, let's see, do I have a light somewhere? I think I do. Hold on. Where are you? Ah, yes, here we go. There we go. All right, here we go. There we go. Maybe that's a little too much light. All right. So you can see the different crystal grains. This is a type of granite. Here's another igneous rock. Both of these cooled underground. When you see bigger crystals, that means the magma, the molten rock that cooled to make this, took a while for it to cool down completely, allowing for minerals to grow bigger and bigger and bigger. Whereas what's interesting, say with this granite and this rock are made of the same exact stuff. It's just this molten rock cooled below ground, this molten rock cooled on the surface of the earth. When molten material like lava hits the surface of the earth, it cools very quickly. So you don't have an opportunity to grow big mineral grains like you see in this granite. If you were to look very closely, there is a little sparkle to it, or if you were to look under a microscope, you'd be able to see some of the microscopic crystal grains. So they're there, they're just not really visible. So we'll talk more about that when we get into igneous rocks. But again, crystal grains, vesicles, these are good indications of igneous rocks. Sometimes you get a mixture of big crystals and small crystals. See, it's a little sparkly, so microscopic crystals, again, vesicles on that one. All good indication of igneous rocks. What else we got here? Oops, sedimentary rocks. All right, so sedimentary rocks, these form from deposited, compacted, and naturally cemented sediments. Forms under conditions of low pressure, low temperature. So a little bit of pressure, a little bit of heat can mush together, compact and cement together sediments. They are made of pieces, or called clasts. So sediment makes sedimentary rock. I'm just trying to find some good examples here. Oh, here's a couple more. Typically, they have earthy colors. They're gritty. They're not much to look at. They're kind of my least favorite type of rock. But you can see that they're made up of pieces, whether big pieces. If you were to feel this, it would feel very gritty. A lot of these would feel very gritty. Again, very earthy colors. While sedimentary rocks might not be much to look at, they do tell one heck of a good story. So, for example here, so this is a type of sedimentary rock called sandstone. It's very gritty, feels like sandpaper. Here's another sedimentary rock. You can see that it's made up of pieces of material. And you can see it's made up of different pieces of rock cemented together, type of conglomerate. And here's another sedimentary rock. In this case, it's made up of shells. This is a type of sedimentary rock called coquina, made up of a bunch of shells. Kind of looks like a Rice Krispie treat, compacted and cemented together. So sedimentary rocks, small pieces of material that have been broken down, compacted, and cemented together. Not much to look at, but they do tell a good story of Earth. They record environments. Most fossils are found in sedimentary rocks, so they do tell a good story. Finally, you have metamorphic rocks. These are existing rocks that have been altered or changed by exposure to some sort of high heat and or high pressure. Sometimes you'll see foliation, which is thin repetitive layers in some metamorphic rocks. You might also see squished or elongated grains. Sometimes they're very shiny. I will say that they're probably my favorite type of rock. They're just really weird, but they also do tell a story of Earth itself. So let me show you a couple of my favorites here. So can I turn this thing on? Let's see. How do I turn this on? Oh, here we go. Is this doing anything here? If I put it under here, hold on. Yeah, it's not doing much. All right, well, we're trying here. I don't know if I do this. This done, maybe? I don't know. Anyway, so looking at this is a metamorphic rock. It's kind of shiny. It's got a little shine to it. If you look at it from the side, you can see some thin layers. This one's even more shiny. Ooh, this is a fun one. You can, I don't know if you can see that from the side, but also some very thin layers, or sometimes it looks like things have been squished and elongated. In fact, this is an igneous rock called diorite. You apply some heat and pressure and you squish this, and then you get something like this, which is a type of metamorphic rock called gneiss. You can imagine squishing this, just squishing it and stretching it out, and this black and white grains kind of stretch out to form something like this. So these are metamorphic rocks here. So different rocks record different Earth's environment. They form different ways. Again, igneous rocks, sedimentary rocks, metamorphic rocks. This is just kind of a good summation of what we talked about. But again, with the rock cycle, they can go any which way. So rocks are really recycled. It's the biggest recycler on Earth is Earth itself. A lot of times recycling rock material. There's only one Earth, and the rock's got to come from somewhere, and it's Earth. So really the rock cycle is all about recycling from one to the next, to a different one, back. It can go really any way, but the different processes of Earth create these different rocks. It's the interaction of the tectonic cycle with the water cycle driving the weather. In between those two things, you find the rock cycle. Now, again, minerals go into creating rocks. In fact, you can get the same minerals making up all sorts of different rocks. So, for instance, quartz, some feldspar, and some micas. So quartz, orthoclase, plagioclase, muscovite, and biotite. If you melt all of those and then cool them very slowly, you get granite. You take granite, you weather it, you break it down, you crush it, and you transport that material somewhere and have it kind of build up, compact it together, cement it together, and then you get sandstone. You take granite, you apply some heat and pressure, and you can get gneiss. So all of these are really made up of the same stuff. It's just how that stuff, how much heat and pressure affected that stuff to form these different rocks. So here's a song. Watch it. It's really, it's one, it's a cheesy song, but two, it's a good song to really help get in your brain the rocks, how they form. There's a little dance that you can make out of it. It's fun stuff. So make sure you're watching that video. And then we're going to go ahead and pause there. When we come back, we'll finish up the unit. We'll talk about mining minerals in Arizona. See you back here in just a minute.